So cerebellum, starting with, I've seen questions with simple things like function. The functions of the cerebellum, number one, is to control tone and posture. If I'm standing, my muscles are already contracting, right? So controlling that, and that function is because of the spinal cerebellar tract, the connection between the spinal cord and the cerebellum, the tone and posture. Also to control equilibrium because of the vestibulo cerebellar coming from the inner ear. And we have done detailed uh, class on the ear. And then another function is for control of voluntary movements. What this is voluntary, not just voluntary. So the cerebellum is going to be receiving information, that is number one, information of two types: intended plan of movement. So the cerebral cortex wants to initiate movement, but before it does that, it tells the cerebellum that I want to perform this movement, and then also information about what actual movement results, which is the feedback. So like you've moved already, and then the cerebellum is told this is the movement that has happened. So then the two are going to be compared, the plan and the actual movement, to for an error to be calculated. And then the corrective output signal go to the motor cortex through the thalamus, and also to the brainstem nucleus, and then down to the anterior horn through the extrapyramidal tracts. Because we want information before it can go out. Information is coming to the cerebellum about me planning to move, so that I plan on the time. Let's say, okay, I want to move like this. How well am I going to do it? What amount of time is it going to take? So that you can just maintain that balance again. And also, the cerebellum is involved in learning new skilled voluntary movements. And this is because of inferior olivary nucleus, which are the climbing fibers. The cerebellum is more organized like the cerebrum, except the cerebrum has got the gyri and the fissures and the sulci. But for the cerebellum, we have got what is known as folia instead of having the gyri, and it has got this part. It looks like a tree. That's why it's known as arbovitae, which means tree of life. Yes, and this is the appearance of the cerebellum. It's important for us at least to know the basic appearance, because so one of the structures they brought in last year's supplementary exam. On top, you can see I've got the midbrain is connected to the pons. Down we have got the medulla, and then we have got these lobes. They come a small flocculonodular lobe, the posterior lobe, which is more down, the anterior lobe, which is more on top. So this guy, the cerebellum, origin is from the hindbrain, behind the pons and the medulla, and then it is separated from them by the fourth ventricle. So between the pons and the medulla and the cerebellum, you have got the fourth ventricle. It is connected again to the brainstem by the peduncles, to the midbrain by the superior, to the pons by the middle, and then to the medulla by the inferior cerebellar peduncle. And then we have got folia, which are similar to the gyrus or the cerebrum. We have got two of these guys, the cerebellar hemispheres, joined on the middle by the vermis. And then we have got three lobes: anterior, posterior, and flocculonodular. You can see the separation between the anterior lobe and the posterior lobe. You have got the primary fissure there. The cerebellum is found in the infratentorial region, because it's down this guy here, the tentorium cerebelli. And it is also divided into gray matter and white matter. The white matter, that is going to be where you're going to find the deep cerebellar nuclei, and there are four. You have got the dentate nucleus, the emboliform nucleus, the globose, and fastigial nuclei. And this is also important to know. The anterior lobe is in front of the primary fissure. As we said, you can see this fissure here. That's a primary fissure. Functionally, the anterior lobe is also known as the spinal cerebellum. Functionally, like you're having that information coming from the spinal cord, going to the cerebellum is actually going to the anterior lobe from the spinal cord. And that information, because it's coming from the spinal cord, it regulates muscle tone. The posterior lobe is also known as the middle lobe. This guy is behind the primary fissure, functionally called the cerebrocerebellum or pontocerebellum. The information that is coming from the cerebrum is actually going, when it's going to the cerebellum, is going to the posterior lobe. Even the ones that is coming from the pons is coming going to the posterior lobe. Just think of pon, posterior lobe. And this information is going to assist in planning and programming of skilled or fine movements. And then the flocculonodular lobe functionally is also known as the vestibulocerebellar, because the information that is coming from the inner ear, from basically the semicircular canals and the otolith organs, the circles and the utricles, about balance is going to the flocculonodular lobe. That's why uh, functionally called the vestibulocerebellum. And so we can see the phylogenetic division. The flocculonodular lobe, this guy, also known as the arch cerebellum, anterior lobe is paracerebellum, and then the posterior lobe is the neocerebellum. Just take note of these names. It's important to take note of them. Flocculo, arch, anterior, just like that. But one thing that for me I'll use to remember is anterior. I'll say anterior. Of course, I've got parietal cerebellum. Maybe I'll be thinking of P parietal with posterior, but just swap those. Parietal cerebellum is with anterior. And then now the arch cerebellum, FA. You know, for you guys who watch football, FA. So flocculonodular, that's the arch cerebellum. And then the posterior, that would be the neo. The cerebellum has got three zones. The middle zone, that's a vermis, and then you have got the intermediate zone, and then you have got the lateral zone. Yeah. And then when you look at each one of these zones has got a function that is going to be able to play. Like for example, the the vermis is going to be involved. You are going to have information going to the medial descending system, basically for motor execution, and then the lateral lobe for motor planning, and then the this other lobe flocculonodular is for balance. And here I want us not to forget about this on the peduncles. The superior cerebellar peduncle is also known as brachium conjunctivum. You know, if they want to, they know you know the answer, but they want to do something so that you think you don't know the answer. Superior cerebellar peduncle is the brachium conjunctivum. The middle cerebellar peduncle is connected to the pons. It is the brachium pontis. Inferior cerebellar peduncle is a restiform body. Okay. Please take note that the middle and the inferior peduncles, brachium pontis, and restiform body are afferent. while the superior, the brachium conjunctivum, is efferent. That's where the information, most of the information coming from the cerebellum will pass through the superior cerebellar peduncle. So this is a diagram that they brought in last year's supplementary exam. You can see you have got the anterior lobe, which is more on top. The posterior lobe is a majority, and then you have got the flocculonodular lobe, which is this small one here. The fourth ventricle there, of course, they are surrounded by the choroid plexus, which makes cerebrospinal fluid. And then these looking like tree, that's arbovitae. And then you have got now the superior cerebellar peduncles, the superior, the middle, and then the inferior. And then you have got the medulla oblongata down. The cerebellum also has got layers, just like the cerebrum. The cortex has got 6 layers. This one has got 3. The outer molecular layer, the intermediate Purkinje layer, and the inner granular. Of these 3, only the Purkinje layer is the only output from the cerebellum. The only output. Every information coming from the cerebellum is from the Purkinje cells. And then the medulla, you are going to have the nuclei. The fastidial nucleus, the globus, emboliform, and the dentate. Globus and emboliform, these are known as interposed nucleus. This is a mnemonic that you can use. Don't eat greasy food. Dentate, emboliform, globus, fastidial. But take note of this, is I think very important. The dentate nucleus is found in the neocerebellum. The emboliform and globus, because these are the same, they're also known as the interposed nucleus. I found both of them in the paleocerebellum, and then fastidial nucleus in the arch cerebellum. Now that's the flocculonodular. And then for the other things, I think we can just look at it. You are going to have afferent fibers going to the cerebellum. You have got the climbing fibers, and then other fibers, and some of them come from the vestibular nucleus, others from the spinal cord, others from the pons. And then you have got efferent fibers. Efferent, you have got those which are going to the vestibular nucleus. So those are known as cerebellovestibular, in the cerebellovestibular tract. Those going to the red nucleus, but they pass from the red nucleus are going to go to the thalamus. So this they are coming from the dentate nucleus of the cerebellum, and then to the red nucleus or the midbrain, so dentato rubrothalamic. And then you have got those which go to the ventrolateral nucleus or the thalamus, dentato thalamic. These are efferents, I mean. So of the 3 layers, the outer molecular layer contains basket cells and sterate cells. Purkinje cell layer contains only Purkinje cells, and then the inner granular contains the granule cells and the Golgi cells. I think this is enough. Of the afferent connections, you have got those which are coming from the spinal cord, from the cerebrum, and then from the vestibular system, basically the ear. Just that is what I want us to take note. These tracks we already did them when we are talking about the ascending and descending tracts. And then the efferent ones, those which come from the cerebellum, you have got cortical pontocerebellar coming from. These are efferents. Remember, they are going right, but I'd put so cortical pontocerebellar. This one is coming from the cerebral cortex to the cerebellum. So this one's supposed to be afferent. And then cerebro olivocerebellar coming from the cerebellum, passing through the olives and then the cerebellum. You can just tell from the name. But what's important is the lesions of the cerebellum. You know already the function of the cerebellum. So the lesions here, they are going to manifest in dysdadochokinesia, ataxia, nystagmus, intentional tremors, different from those seen in Parkinson's, which are resting tremors, and also hypotonia. You can see some tests that you can perform for hypotonia. like the deep tendon reflexes, there's going to be loss of cerebellar influence on these guys. There's going to be disequilibrium. You can see the gait is not good. There's tandem walking. There's also going to be a positive Romben sign, and the pronator drift is going to be there if there's damage to the cerebellum. And then another thing is that point to point test will be absent. Also, the heel to shin will be absent. This dadacokinesia also will be absent there. There's also going to be nystagmus. Yeah, so those problems. So we can now try to answer these questions. The nuclei related to parao cerebellum are globose and dentate, dentate and fastigial, globose and emboliform, emboliform and fastigial. Which one can we pick? Okay, thank you so much. The globose and emboliform. Don't eat greasy food. So the two on the middle. Don't eat grease, eat and grease. Emboliform and globose. The most medial nucleus in white matter is the most lateral is the dentate. So which one is the most medial if you use the mnemonic? Don't eat greasy food. The fastidio, thank you. From which nucleus afferent do fibers go direct to Purkinje cells? From which nucleus afferent do fibers go direct to Purkinje cells? Fastigial nucleus, vestibular nucleus, inferior olivary nucleus, red nucleus. Yeah, the inferior olivary. Lateral lobe of cerebellum, neocerebellum, integrates the vestibule cerebellospinal reflex, receives inflow from the cerebropontine fibers, primary primarily integrates proprioceptive information from joints and ligaments received from the dorsospinal cerebellar tract, controls rapid alternating voluntary movement. Which one can we pick? The lateral lobe or cerebellum, the neocerebellum? D. Is there anyone else with an option? Okay, this thing is come from here. Is from here. You can see what's happening for the vermis and the paravemo for motor, and then for the lateral for motor planning. So doc, you picked which one? D. Okay, so we know obviously it's not the vestibular. Receives inflow from the cerebropontine fibers. Primary integrates proprioception. That's still balanced, so that's not true. Controls rapid alternating voluntary movements. Okay, so for me, it's just between B and C because about balance, obviously, it's not this one. So motor planning, yeah, I can also agree with D about the voluntary movements. Yeah. Okay, though I didn't really mention the specific nucleus, but the lobe to which they were going, and those lobes. It's we are mentioning the anterior, the posterior, and the flocculonodular lobes. But here they are talking about the functional part, which is those divisions. I don't know if that one is okay. Yeah. Concerning the cerebellum, provides timing signals. Motor learning has an overall inhibitory output to the upper motor neurons, sends error signals to the rest of the cortex. Of the above are true. Which one can we pick here? Has an overall inhibitory output to the upper motor neurons? Or motor learning? Motor learning. Is there anyone with a different option? E. Okay. Any anyone else so that they can now give us. So the one who gives us what they feel decides which one we pick. Hope it will not be another option from the two. Anyone else? Okay, because timing provides timing signals. Like remember what we are saying, when information that is coming from the cerebral cortex is going to go to the cerebellum and you want to respond. Let's say for example you want to perform a motor action, like you want to move your leg. So I want to calculate the time it will take for you to be able to step, let's say, on the next step, so that you can maintain that balance. So the cerebellum is being involved also in that. Also in motor learning, we had mentioned that over inhibitory output and also the sense error signals. We also did mention that. So basically, all of the above for me, all of the above. Yes. Mm, yeah. Oh, I see. So from these functions that we have here, we can see the first one: control of muscle tone and posture via the spinocerebellum, equilibrium, vestibulocerebellum, control of voluntary movement. So first the cerebrum is going to send this, the intended plan of movement and the actual movement. And then there's going to be corrective output signal from the cerebellum, and then that goes to the motor cortex and also to the brainstem. That's why I've picked it as one of the answers also. Yes. A patient has the ability to stand with open eyes but falls with closed eyes. Now, I love that one. I just want to show you something so that as you even answer. So here, when you are comparing the dorsal column, medial meniscus, and the cerebellum, the good difference, if there's a lesion to the cerebellum, it manifests the same like the spinal cord lesion, except you can see for the cerebellum, patient is going to sway on the sides with eyes closed or open. Whether you open your eyes or you close your eyes, when there's an injury to the cerebellum, there's going to be imbalance. But for the spinal cord, if there's a lesion, there's going to be the swaying to the sides only when your eyes are closed and not when they're open. Remember the rhombering sign where we are holding so that they don't fall. So which one is that? A patient has a ability to stand with open eyes but falls with closed eyes. A lesion of which pathway is likely responsible for this symptom? Dorsal spinocerebellar, lateral spinothalamic, ventral spinocerebellar, dorsal column syndrome. Which one can we pick? D. Thank you. Is there anyone with a different one? Dorsospinocerebellar. Okay, so is there another one? Oh, there is also C, the ventral spinocerebellar. So now we have got A, C, D. Let's have a another one. Let's hope they'll pick one of the three. Anyone else? Okay, I love that. Yeah, so we can go for D. Remember, we are from mentioning that the dorsal column, when it is injured, there's going to be that positive rhombering sign. When you close your eyes, you might fall, but when you open your eyes, it's you are intact, you're not fall. But if it's the cerebellum, whether you open your eyes or you close your eyes, if there is a lesion, you can fall. Hope we are good with this one. Ventral Ventrospinocerebellar tract enters the cerebellum through the dash. So these are things that I just skipped for the sake of skipping, but just quickly so that I know we did these things, some time back. The ventrospinocerebellar, remember, it's coming from the spinal cord to the cerebellum. The ventral one, or the anterior guy, is passing through the superior cerebellar peduncle. And it's very much interesting because this guy, you can see, like, it's coming from our muscle spindles and then going to the spinal cord in the spinal border cells in lamina 7. And then what is happening is that we are decasseting, we are going to the opposite side, and then we start going up in the anterior spinocerebellar tract. And then by the time we are reaching the pons, we are again now going to the cerebellum. And you can see it is on the opposite side. So the ventral is carrying contralateral information from the muscle spindles. The dorsal is different. You can see this guy, when the information reaches in the spinal cord, you go to the Clark's nucleus or the nucleus dorsalis, and then you are going to the on the ipsilateral side via the inferior cerebellar peduncle. The anterior was going through the superior. This one is through the inferior. We also have the cuneo-cerebellar, which also goes through the inferior. So it's only the anterior spinocerebellar that was going through the superior. That's the only thing I wanted to mention. So the ventral spinocerebellar tract enters the cerebellum through the. I think this was last year's exam. I don't know if that was up or final exam. Brachium conjunctivum, tectoplate, middle cerebellar peduncle, rest from board. Which one can we pick? Yeah, brachium conjunctivum. So you see, in case I've just swatted the superior cerebellar peduncle. A lesion of which of the following structures may result in incoordination, reduced posterior tone, and peduncular phase stretch reflexes. Middle locomotor system, motor cortex, premotor cortex, cerebellum, superior colliculus. Yeah, it's a cerebellum, right? Of all those, even the symptoms we're reading, like the pendular reflexes. Regarding cerebellum, after lesions, disturbances are contralateral to the lesion. It coordinates somatic motor activity and regulates muscle tone. Sensory information received by the cerebellum is acted upon at a conscious level by this structure. Speech is rarely disrupted after cerebellar damage. All are correct. B. It coordinates somatic motor activity and regulates muscle tone. That's correct. But do we have any other answer that appears to be correct? Yes, doc. Yes, yes. Or this one, the cerebellum. Sure. Okay, so here our doc has picked B, and that's correct. But let's look at the other options. Is there any answer that someone knows? Okay, this option is correct. After lesion disturbances are contralateral to the lesion, sensory information received by the cerebellum is acted upon at a conscious level. Speech is rarely disrupted after cerebellar damage. Mhm. Okay. Yeah. Mhm. Yes. Okay. So what will happen if there is injury to the cerebellum, since it's most of this for mostly by the Broca's area? Is it going to be affected or not? So meaning that this is correct? Okay. Okay. Is there another option before you can move? Is there anyone who is thinking about any other option before you can move to the next? Okay. Because if you look at D, for me, just to support also the doc, I would disqualify that because for the cerebellum, remember I've got some fibers that are passing from, like, let's say some fibers that are coming from the cortex, they are going to the cerebellum. But I was thinking of the cortical bulb, that is a pyramidal band, and that is not really going to the cerebellum. But say maybe we have got a fiber that is going to the cerebellum, or we can just talk about the vestibulocerebellar, where someone is disoriented already with they lack the balance, so the balance is just to do with the motor aspect of them, let's say maybe standing or something like that. But to some extent that is also going to disturb the speech. So here we want what is true when it comes to cerebellar cortex injury, and the speech is really disrupted after. Yeah, this is true. Speech will be really disrupted because really there's not much effect on speaking, just like the dog said, because unless maybe if we're talking about hearing a bit, we can say maybe because the Kamenev is going, they are going together, but even hearing won't be much disturbed because of the. Yes. Yeah, so they can't even be correct because speech is rarely disrupted after cerebellar damage. Anyway, I've seen now this option is so it rarely. Yes, but yeah, so it will be disrupted. Okay, so and then the dips nuclei of the cerebellum includes which of the following? Globose fastigoembodies form dentate globose substantia nigra. Ah, so which one? It's A, right? Yeah. Fibers of the corpus callosum, which radiate into the temporal lobe. Okay, this guy is supposed to be on the cerebellum. Cerebrum, not cerebellum. So answer it on the cerebrum. All the following structures form part of the cerebellar circuitry except cerebellar pedanco, pontine nucleus, red nucleus. Let's try to answer this one from last year's supplementary. What can be A? Anterior lobe. And then we have got B. How about B? Cerebellar cortex. And then we have got C. The white matter. the above it, yes. And then we have got D, the tree of life. Above it, how about D? So D is the posterior lobe, yes. And then E, the fourth ventricle, yes. And then F, choroid plexus. So we can say choroid or the fourth ventricle, yes. How about F, yes. So the flocculonodular lobe. And then G, the medulla oblongata. And then the H, inferior peduncle cerebellum. I, the inferior is the rest form body. And then I, the mid. And then the last, bracham pontis. And then the last one, J, this, yeah. And that is it for these questions which I'd put here for today.